Thank you, Eric, for providing that regional context, both for the presentation and for the restoration project. It's been a real great pleasure to work with Eric and the Science Advisory team on how the Aliso Creek Estuary restoration fits into the larger effort to restore our coast in Southern California. And thank you, everyone, for being here tonight to support that, support the estuary restoration plan, which I'm excited to be a part of. This is a very unique project, I feel, in a very beautiful location. So I'm going to give you an overview of the estuary restoration plan. For those of you that were here for the tour earlier, I'm going to repeat myself a little bit, but go into some more details too and show you the conceptual restoration plan. First, I want to start with our project area for the plan. It includes about 11 acres here, starting upstream at this bridge at the ranch, going downstream about 2,000 feet of creek to the mouth where the creek enters the ocean. The project area includes portions of the Aliso County Beach Park, this beach overflow parking lot on the inland side, as well as this portion of the park here on the ocean side. The land within the project area is owned by the County of Orange, again, for the Aliso County Beach Park. And this portion of the property and project area along the north bank of the creek is owned by the South Coast Water District. And then we have the ranch at Laguna Beach upstream. Coast Highway crosses the creek and is under the jurisdiction of Caltrans. So there are a number of water and wastewater utilities within the project area, as well as other utilities that need to be considered within the restoration plan. Includes sanitary sewer pipelines in green, recycled water pipelines in purple, and the domestic water supply pipelines in blue. So we're thinking about how to restore the habitat, but we need to also consider the existing conditions and the constraints that need to be worked around in order for the estuary to be restored. Getting to the existing conditions of the estuary and the habitats, this map shows the existing habitats within the estuary. Really, today, those habitats are limited to the channel itself, shown in blue. So the estuary is currently largely channelized due to historic filling of wetlands and modifications to the ecosystem and the watershed and the hydrology. There are virtually no native wetland habitats in the system currently. There are some non-native wetland habitats shown here in brownish color with some native plants mixed in. There are some native upland habitats adjacent to the creek, which of course continue up to the Aliso Canyon hillsides. But really, it's just the channel itself today. The existing habitats are also affected, again, by changes to the hydrology. We have the creek watershed flowing into the estuary from upstream, and I'll talk more about how that's changed over time. And then at the mouth, conditions have also changed. So at the mouth, what happens naturally is that waves push sand up onto the beach and into the mouth of the creek, closing off the mouth of the creek, building up a sand berm that separates the estuary from the ocean. And that's a natural process that would occur naturally for these type of systems. We've observed it in other systems as well. And we can see historically, which I'll show you evidence of that. Today, the mouth is breached, meaning it's excavated. People dig out the mouth of the creek to allow it to flow over the berm into the ocean. And that happens, people that are using the beach recreationally are doing that to allow the flow to scour out the opening, the mouth. It forms a standing wave. and people ride that wave. And I'm sure some of you have seen that. You can go on YouTube and see it. It looks incredibly fun, but unfortunately, like some other fun activities, it's actually illegal. So the county lifeguard patrols and enforces so that the people don't breach the outlet while they're on patrol. There's some indication that it happens outside of that, of when it is patrolled. And the county itself also has a permit to occasionally breach the outlet for their purposes to manage the mouth and how it migrates on the beach for safety. So while historically or naturally the estuary it closes, currently it is breached when it wouldn't otherwise be open. So that is a key change to the system and the habitat. So as part of the restoration plan, we monitored water levels and water quality conditions within the estuary during the summer of 2016. And we actually had a great experiment in that the mouth was largely open between March and May 2016. People were actively excavating and riding the wave regularly at the mouth, so it was open most of the time. And what happens is that water flows out when it's open. On the following high tide, waves push water into the estuary, mixing with creek flow from the creek. And on the following high tide, that water flows back out. And water within the estuary during that period of opening, it's largely ocean water influenced in terms of salinity, temperature, and dissolved oxygen. In the latter part of the summer, in June to July 2016, the county stepped up its enforcement, as Supervisor Bartlett spoke to. I think there was signage and an extra effort to keep it from being breached, and it was closed during the majority of this time. And we could see how the system responded. And what happens is that the mouth closes, the waves build up the sand berm to an elevation where the lagoon can't flow out. And so water coming in from the creek pools and traps salt water at the bottom that is there from when it was open and from waves that do wash over the berm. And that stratification creates an interesting situation where the high levels of nutrients coming in from the watershed are feeding algae growth during the day and die off at night. So this is a process called eutrophication and leads to low dissolved oxygen levels in this trapped layer of bottom water. And that's potentially a concern for the existing habitat and the restored habitat within the existing channel. Though, as I'll show you for the restoration, we're looking to create shallowly inundated wetland habitat that would be outside that the channel and lower dissolved oxygen conditions. And we see that over time, this trapped bottom water is being pushed out as the creek flows drive seepage through the berm. So that's a kind of snapshot of current conditions. And as Eric explained, our restoration plan is informed by what was historically present in the Liso Creek estuary. Currently, there's really no native wetland habitat. Historically, we can see from the historic maps and historic ecology study that Eric was involved in, and these maps from 1885 that were produced to provide a snapshot of what habitats were there historically. We can see that there was a meandering creek channel down to the ocean with vegetated wetland habitats along both banks of the creek, and river island bar habitat where sediment was depositing on the inside bends of the river here. So a real diverse extent and large extent of habitat. There was about 14 acres of wetland habitat within the system historically. We can see after 1885, historic photo records of what those habitats look like. So these arrows show the field of view for these photos I'll walk you through. You can see the vegetated wetland in the estuary in the valley here. Moving slightly downstream, again, you can see the vegetated wetland, so these two areas. This is the original road going up the canyon, and then it crossed a bridge and circled back this way. That photo was from 1923. This photo shows from the north or west side, looking out over the mouth of the estuary. You can see a wide sandy beach. It was a popular destination back then as well. The mouth was closed in these photos, as you can see. And you can see people using the wetlands as well here. In 1926, the Coast Highway Bridge was constructed. Originally included 2.5 arches. So here's 1, 2.5. So currently there is only this arch open. This has been closed and is the tunnel that goes from the inland side to the beach goes through what was this arch, and this arch has been closed off. Again, you can see the mouth closed in a much larger extent of open water habitat here at the mouth of the estuary. Looking from the other side, you can see again the bridge and the estuary mouth here, and the beach berm closing off the mouth of the creek. So if we take those historic maps and overlay them on current conditions, you can really see how the system has changed and how the habitats have been lost. So these are those same habitats I just showed you from the map overlaid on the current aerial photograph. So you can see the creek channel has been straightened through the wetlands. These wetlands have been filled to create this parking lot. As well, the mouth of the estuary here has been filled. There's currently a jetty along the creek right here that channelizes the creek as it goes to the ocean. And again, within the project area, historically there were about 10 acres of wetland. Today, it's really just the channel. Other than that, there's no wetland habitat. So the other modification to the ecosystem that's important to address with the restoration are changes within the watershed. There's a 35 square mile watershed for Aliso Creek that drains down to the estuary. There's a water quality improvement plan in progress to address pollutants from the watershed and elevated flows coming down the watershed from development in the watershed. So that includes irrigation and runoff from over-irrigation and fertilizers that those flows carry down the creek to the estuary. What we can see is that historically, if we look back at the flow record, from the 1930s to the 1950s, there was essentially no flow in the creek during the dry season. It was an ephemeral channel that was probably dry in some stretches. Down towards the mouth, there was probably some groundwater and creek flow that was feeding into the estuary. But due to development in the watershed, that's changed greatly. Today, the average flow midway up the watershed is gone from about 0 to 1 cubic foot per second. So there's a constant flow during the dry season feeding into the estuary again, and carrying nutrients from fertilizer with it. So to summarize the key modifications that have occurred to the system, the historic wetlands have been filled in, the creek channel has been channelized, reducing the wetland extent. The dynamics of the mouth have been changed due to artificial breaching of the mouth by people and occasionally by the county. The dry weather creek flow into the estuary has increased due to development of the watershed. And as a result, the ecosystem has experienced loss of habitat functions and wildlife species. One example is the endangered tidewater goby, which is an endemic fish species to this type of small closed creek mouth estuary system. the tidewater gubby was present in the estuary until about 1978. After that point, it's no longer found in the estuary, and this is actually, the restoration provides a great opportunity to actually potentially reintroduce the tidewater gubby. So that leads us directly to what restoration actions we can take within the plan to address these modifications to the system. We can restore and expand wetlands. We can reduce artificial breaching of the mouth. We can reduce the dry weather flow from the watershed into the estuary and improve the quality of the water flowing into the estuary, and thereby restore not only habitat, but the function of the ecosystem and the vegetation and wildlife for the entire ecosystem. So, in order to develop the restoration plan, we have developed the goals and objectives that Eric described. We considered a range of alternatives in terms of extent of wetland restoration and combination with management scenarios for the dry weather inflow and the mouth breaching, as well as phasing. We've analyzed those alternatives. You can see them here. We've modeled them, compared them to the goals and objectives, and in coordination with the science team, selected a preferred plan that I'll get to soon here. And we've also then looked at options for public use to allow interaction with the restored habitat. And we've met with stakeholders, including Orange County South Coast Water District, to coordinate on the restoration. So, to finally unveil the conceptual restoration plan, the preferred plan of the alternatives considered is to remove the current parking lot on the inland side of the beach park and to restore that area back to wetland habitat as it was historically. So that would create several acres of vegetated wetland connected to the creek channel once again. On the ocean side, the existing jetty, which currently channelizes the creek, would be moved back to the edge. This existing area where there is a park, a picnic area and a playground, that could be relocated, and I'll show how that could work next to create more space and expand the estuary on the ocean side here. So expansion of wetlands is one key way to restore the estuary, but to address the other modifications to the system, the plan also involves reducing dry weather creek inflow to the estuary, so bringing it back to what the levels were historically. And in the long term, as part of the restoration plan, that could happen through watershed management and improvements in the watershed. The plan also calls for reducing artificial breaching at the mouth, and so this would be continuing the current county enforcement, but also using the restoration project and improvements in public access and interpretation to educate the public to what the benefits are of the restored system, why we should care about this beautiful system, what species and habitat it supports, and why breaching the lagoon or the estuary is detrimental to those habitats. Finally, in the long term, the plan involves expanding the Coast Highway Bridge. So you can think of that as opening back up or restoring the historic bridge to allow for a wider corridor for the creek and habitat under the bridge to connect the eastern and the western portions of the creek. This, of course, is a long-term restoration plan and vision that will get implemented in phases over time. So those near-term phases would not include expansion of the bridge. There's no current plan to retrofit that bridge, but the plan will look opportunistically if and when that bridge is widened to coordinate that with the restoration plan. So the bridge expansion would be part of a future phase. The expansion and creation of restored wetland habitats that could be achieved in near-term phases at varying extents. So possibly the ocean side expansion of the western estuary could happen first before the parking is removed on the inland side. Potentially a portion of the parking could be removed rather than all of it as an initial phase. Thinking about the reduction in inflow from the watershed, again, the long-term plan is through watershed management to reduce the inflow. We actually have the opportunity now, in cooperation with the South Coast Water District, to use their urban runoff recovery unit at the coastal treatment plant, which is a few miles upstream, where they have the system that has the ability to divert flow from the creek during dry weather. And that water, which is imported water used for irrigation, making its way into the creek, to divert it out of the creek, treat it and recycle it and put it into the recycled water system. Therefore, sustainable reuse of water supply that could also benefit the estuary. And that's something that could occur as a near-term phase to benefit the estuary. All of this would be done within an adaptive management program, both the near and the long-term phases, and I'll speak more about how that would work. And again, this plan does involve removing a significant number of parking spaces here. There's about 100 or so parking spaces in this area. The primary objective of this plan is to restore the estuary and its habitats, but of course we want to look at how not only the parking could be reconfigured, but how the overall public access and interaction with the restored habitat could be enhanced so that people can experience and appreciate the beauty of the restored ecosystem, learn about it, and therefore become stewards of the restored ecosystem at the Aliso Creek estuary. So this shows some options for reconfiguring the current public use and enhancing it. So again, removal of the parking here could be reconfigured and replaced with a new parking lot on the north bank along Village Lane. This is currently South Coast Water District property that they are using for construction staging right now. There is an opportunity to create a large number of spaces here and also a visitor center that would, again, provide educational opportunities, programming, and would also take advantage of some really incredible views at this location. Here, one, looking out the bridge to the ocean, and two, looking upstream into Aliso Canyon. That, of course, would move access, which currently people park in this parking lot and can walk through the tunnel to the beach. By moving that parking to the north side, we want to maintain that access and actually improve it. So people parking in this location would get a great view over the wetlands. There would be a new interpretive trail along the north bank here. And we've looked at a number of options to bring people down to the beach. That could involve a signaled crossing of Coast Highway, which people could cross and then walk down the stairs to the beach. It could also involve a new bridge, pedestrian bridge at Coast Highway here, or potentially a new bridge across the restored estuary at either this location or this location. Again, at the mouth, in order to allow for expansion of the estuary, this area would be reconfigured. The playground could be relocated closer to the driveway. The picnic area could be reconfigured in this location, and people would have the opportunity to interact with the restored habitat and estuary here. So these are options for how the public use could be reconfigured and how the public could appreciate and interact with the restored system. Really, the key piece of this is the habitat restoration, of course. And so to jump back to the habitat restoration and explain that in a little more detail, what we're trying to restore here are, again, estuary habitat, including vegetated marsh, as seen here from another system, open water with a closed beach berm, that type of habitat, but with vegetated wetland banks along the edges, transitioning up into riparian habitat on the upstream end. The wetland vegetation would be planted as part of the restoration, and that palette of plants would include a range of native estuary wetland plants, including tules, cattails, and pickleweed. And we expect that that restored habitat would support a range of estuarine wildlife, including a number of bird species and fish species, in particular the endangered tidewater goby that I mentioned earlier, which the U.S. Fish and Wildlife Service has a recovery plan that identifies Aliso Creek Estuary as a prime location for the recovery of this endangered species to potentially reintroduce it into the restored ecosystem and potentially save it from going extinct. So it's a great opportunity. And again, to jump back to the adaptive management portion of the restoration, adaptive management is a common approach within restoration using the scientific method to test, refine, and improve management of the ecosystem and restoration outcomes. So the components of this plan would include management of the dry weather inflow, reduction of artificial breaching at the mouth, the vegetation that is planted to control invasives, potentially the wildlife that's using the site or reintroduced to the site, as well as public access and making sure that people can interact with the site without disturbing the habitat. And the way this adaptive management process would work is an adaptive management plan would specify actions that would be taken, what would be monitored. There would be baseline monitoring preceding the process, and then specific management actions on these components would be implemented. The results would be monitored and assessed, and then a decision would be made whether to continue with that management or to revise it according to the adaptive management plan. So how do we know that the ecosystem restoration of this estuary will be successful? Well, if we see that the physical processes are restored to the historic dynamics and support the restoration of restored habitats, so including water levels, closure of the mouth, water quality conditions, if we can restore those processes in a way that support the habitats, we know this system will be successful. We would also monitor for habitat structures and functions that ensure that the revegetation is not being invaded by invasive species, and monitor the wildlife used to see what species are using the site, as well as another measure of success. And again, these are all geared towards achieving the restoration goals, that the public is able to access and engage with the site and are becoming stewards of the restored system. Okay, finally, how will the estuary change in the future? Of course, this is not a static system. It's a dynamic ecosystem that will change in response to storm events, as well as future sea level rise and climate change. The intent here is to design a system that can be self-sustaining and resilient to change. So by expanding the estuary and allowing it to respond naturally within the restored footprint. The idea is to restore a system that doesn't require active management to maintain a certain configuration, but is resilient and that will continue to support a vegetation community that can support the native wildlife. This is this figure notes some of the changes we expect with sea level rise, there to be beach erosion, increase in the beach berm height, and increase in the estuary water level. But we also expect sediment deposition and accretion within the wetlands, so there is the potential to sustain these wetlands with sea level rise in the future. And this restoration plan can restore the estuary as one piece within an overall plan to improve the resiliency and sustainability of the coastal area here in South Laguna Beach and in Aliso Creek. So our next steps with the restoration plan are to complete our technical analyses and the conceptual design, including some additional engineering, cost estimating. We will have a draft conceptual restoration plan report available in December of this year, It will be available for public and stakeholder review and comment in early January 2018. And then we'll, in response to those comments, prepare a revised final conceptual restoration plan at the end of January 2018. What comes after completion of the restoration plan? That process will be discussed within the restoration plan itself and will involve building partnership with the key stakeholders, securing funding for the next steps, environmental review, including CEQA and additional opportunities for the public to review and comment on the project, detailed design and regulatory permitting, and then ultimately phased implementation and management of the restoration. And with that, I'll close, and Eric and I and Ed are all available to answer questions. Thank you for everybody for your time.